If you follow artificial intelligence, um, you know, it feels like we're either right on the verge of, well, true consciousness, or maybe just a few bugs away from total chaos.
Right. It's a confusing landscape.
But what's really underneath it all? Today we're going deep.
Okay.
Right to the source, the foundational philosophical roots of AI.
Exact.
We're tracing the path of logic itself, you know, from ancient rules of deduction all the way to modern deep learning.
To understand why AI keeps hitting these invisible walls and, crucially, what needs to change for real progress.
Yeah.
We want to move past just the hype. We're asking, what is this intelligence AI is trying to replicate?
Okay.
The real tension here, the thing we're diving into, is between that rigid, almost perfect world of symbolic logic and the messy, context-heavy nature of how humans actually think.
Right.
So for you listening, the mission is to see that the limits AI faces today, they're often philosophical. They stem from assumptions made, well, thousands of years ago.
Okay, let's unpack this then. We have to start where structure itself kind of starts.
Yeah.
Aristotle.
The beginning, yeah.
His work gave us formal logic. It provided the very first real mechanism for structured rules of deduction.
And that became the absolute foundation for early symbolic AI systems, you know, the so-called expert systems.
Because if you want a machine to reason, you first need a formal language, a way to actually express that reasoning.
And that's the crucial link right there. The early idea of what intelligence was in AI, the cognitivist paradigm, it was built entirely on this symbol manipulation approach.
That phrase, symbol manipulation, sounds technical, like programming, but it's actually straight out of philosophy, isn't it? It was like a whole belief system about knowledge itself.
It absolutely was. This whole symbolic approach came directly from applying logical empiricism,
Okay.
which was this dominant theory from the philosophy of science back then. Think of logical empiricism as the belief that basically the entire universe could be written down, like one giant, perfectly logical rulebook.
Everything fits.
In this view, yeah, all knowledge must be perfectly structured, governed entirely by formal logic. Every single judgment, every action can be explicitly laid out as a set of rules. You know, if you follow rule A, then outcome B must logically happen. No ambiguity.
And the genius, or maybe the initial insight, of early AI was realizing that computers, well, they're perfect rule followers. They excel at manipulating symbols.
Exactly. They could perfectly emulate this formal logic.
So early AI did have some successes.
Oh, absolutely. They achieved, you know, reasonable success, but in very constrained areas. Knowledge representations, specific decision-making tasks, classic games like chess.
Because the computer could just execute these complex formal algorithms without error.
They worked beautifully, provided the domain was perfectly defined and all the rules were known and complete.
But the real world, as well, anyone knows,
Yeah.
it's just not a perfectly defined domain, is it?
Precisely. And this is the critical pivot point. The minute symbolic AI tried to step outside that clean, perfect environment.
Like the chessboard example.
Right? Or a simple diagnostic tree. The moment it tried that, it just hit a wall. It failed, often spectacularly, when attempting to model the dynamic messiness of actual human thinking.
Okay, so here's where that formal rigidity starts to really break down.
Yeah.
What happens when the AI has to deal with a situation where the rules seem to clash?
Yeah.
Or the information is just fuzzy, incomplete?
That's the first massive roadblock, ambiguity and context. A philosopher, Dascal, really highlighted this failure.
Yeah.
These symbol manipulation systems, they just can't function properly when faced with ambiguity or, you know, contextual variation or just plain missing information.
You give an example.
Sure. Imagine an expert system designed for legal reasoning. It might have, say, 10 crystal clear rules about what constitutes intent.
Right.
But in a real court case, figuring out intent involves interpreting body language, historical context, social nuances, maybe even tone of voice. None of that stuff can be neatly captured in a formal symbolic rule.
So the system just stalls.
It basically locks up. It can't figure out which piece of information is the relevant one or how to resolve facts that seem to conflict based on its rigid rules.
And that inability, that struggle to filter the important stuff from all the noise,
Yeah.
that seemed to lead straight into the next big problem, right? The famous frame problem.
Oh, the frame problem. Yeah, detailed by Pat Hayes way back in '77.
That's just that exact.
It's actually one of the deepest philosophical challenges for AI. It tackles the fact that in the real world, when you do something, most things, well, they don't change.
Okay.
Like if you pick up your coffee cup from the table, the cup moved, yes, but The table didn't suddenly change color. The walls didn't disappear. Your chair is still there.
Right. Seems obvious to us.
Obvious to us. But a purely symbolic system has this incredible burden. If its knowledge base contains, say, 10,000 facts about the room, and you move that one cup.
It has to update the cup location fact.
Yes, but it also has to logically verify and explicitly represent that the other 9,999 facts remain unchanged. It has to confirm the ceiling didn't vanish, the floor didn't turn into lava, the window is still closed. It literally cannot perceive which facts are actually relevant to the action you just took.
So it gets bogged down.
Completely bogged down in an potentially infinite calculation of what didn't change. Humans do this effortlessly, intuitively. We just assume the background frame stays stable unless there's a reason to think otherwise. The symbolic AI drowns in irrelevant data.
That inability to grasp relevance, it really sounds like a fundamental lack of common sense.
It is, essentially. And this brings us neatly to the philosopher Hubert Dreyfus and his really quite devastating critique of early AI.
What was his main point?
Dreyfus argued that true human expertise, the thing that makes someone a master craftsman or a doctor or a mechanic, isn't just about following rules. It's characterized by intuitive or tacit background knowledge.
Tacit knowledge, the stuff we know but can't easily explain.
Exactly, the stuff we can't just write down in a rule book.
Yeah. Can you give us an analogy for that? How does tacit knowledge differ from, say, the symbolic knowledge in an expert system?
Okay, think of a master car mechanic versus a complete beginner who's just meticulously following a very detailed repair manual.
Right.
The manual is the symbolic system. If you see the symptom, then perform step X, then check part Y. The beginner follows the rules perfectly, step by step, but it takes them, 3 hours to diagnose a tricky problem.
Fair.
The master mechanic walks in, listens to the engine for 5 seconds, maybe smells something faint, and just knows. Intuitively understands the core issue in minutes, bypassing hundreds of steps in the manual.
That intuitive feel for the situation.
Precisely. That skill, that embodied understanding, it just cannot be fully captured by formal rules. Dreyfus basically challenged the entire information processing assumption underlying early AI. He said, human thinking is way more than just logical computation over abstract symbols.
That sounds like a pretty fundamental, maybe even fatal flaw for any system trying to get beyond simple logic puzzles or games.
It points directly to what might be the biggest philosophical hurdle of all, one that sort of underlies both the frame problem and this lack of tacit knowledge. It's called the grounding problem.
Okay, so we've been talking about how early AI was really built on this epistemological tradition of representation using these static models like ontologies or graphs to stand in for the real world.
Right. And the grounding problem is the direct consequence, the failure point of relying solely on that representation. It asks a really simple but profound question. How does the computer system actually connect its internal symbols?
It's like the variable cat in its code.
Exactly. It's abstract representations like the word cat, or maybe a node in a graph labeled cat. How does it connect that symbol to the actual thing in the real world? The furry creature purring on the keyboard.
So if the AI's internal symbol for cat is only linked to other internal symbols, maybe feline, mammal, has whiskers,
but never, ever connected to a sensory input, like seeing a cat or hearing it meow or feeling its fur or interacting with one in the world,
then the symbol has no real meaning.
Then its meaning is completely ungrounded. It's purely syntactic manipulation. It's like, imagine being locked in a room with only a Chinese dictionary and trying to learn Chinese.
You could look up definitions.
You could learn that one symbol corresponds to another symbol, maybe build complex sentences by following grammatical rules found in the dictionary, but you would never truly understand what the symbols refer to in the real world, what a mountain looks like, what water feels like, until you actually step outside that room and experience them.
I see.
That fundamental inability to link internal abstract models to the dynamic, changing real world, that's precisely what capped the potential of purely symbolic AI.
Now, I think a lot of people listening might assume, okay, but we move past that with deep learning, with statistical models. Are you saying this philosophical issue, this grounding problem, it still affects us today?
It absolutely does. And this is the crucial link to right now, to modern AI. Look at the large language models, the generative AI systems we have today.
They're incredibly fluent.
Amazingly fluent at generating text or images or code. But their outputs often lack real intentionality, they lack common sense sometimes, and crucially, they can produce these factual errors, what we call hallucinations.
Right, making things up convincingly.
They can generate a perfectly structured, logically sounding argument about, say, a historical event that never actually happened. Why? Because the internal symbols, the tokens, the weights in the neural network, they're statistically related to each other based on the vast amounts of text they were trained on.
But they're still not truly connected.
They are still not fundamentally grounded in the user's specific context or verified against external real-world facts in a robust way. It proves again and again that AI intelligence can't rely only on internal representation-based theories of knowledge. Something is still missing.
So the failures we saw with early symbolic systems,
Yeah.
they weren't just, technical glitches or bad programming. They actually signaled a necessary philosophical shift, a rejection of that rigid logical empiricism as the only way to define intelligence.
Exactly. The AI research community was forced to pivot.
And that pivot in AI actually mirrored a bigger shift happening in the philosophy of science itself, right?
It did. Science as a whole has moved quite dramatically away from that strict positivism, that idea of perfect logical rules governing everything. We now understand scientific practice as being much more of an interpretative enterprise.
Oh, so.
Well, think about scientific revolutions. The big paradigm shifts Thomas Kuhn wrote about.
Okay.
Those shifts aren't driven solely by purely rational step-by-step logical deductions based on new data.
Yeah.
They often involve intuition, community consensus shifting, gestalt switches in perception, things that formal logical rules alone simply cannot account for.
So the failure of purely symbolic AI wasn't just, oh, that program didn't quite work. It was more like, hold on, the whole philosophy of knowledge that this program is based on, it might be incomplete.
Precisely that. It forced AI researchers, sometimes reluctantly, to move towards more experimental methods, pattern learning approaches, probabilistic reasoning, basically, the kinds of things that laid the groundwork for modern machine learning and deep learning.
But here's where it gets really interesting again. If pure symbolic logic failed to capture general intelligence, why isn't the answer just to ditch it completely and only use statistics and pattern matching? Why is the source material we looked at so insistent that symbolic logic is actually still necessary?
Because of traceability and verification. There are specific, often narrow domains where symbolic logic is still absolutely indispensable.
Such as?
Think about legal reasoning systems. You need to be able to trace back every single step of the reasoning process to verify it against established rules and precedents.
Okay, that makes sense.
Or controlling complex, safety-critical automatic machinery, or doing formal mathematical theorem proving. In those kinds of unambiguous, highly rule-bound environments, symbolic AI is perfect because its reasoning is transparent, explainable, and verifiable. You know why it reached a conclusion.
So the ultimate goal isn't replacement. It's not logic or statistics.
It's synthesis, integration.
Hybrid systems.
Exactly. Hybrid cognitive architectures. To overcome those deep limitations, ambiguity, the frame problem, the lack of adaptability, which, remember, are all kind of downstream effects of the grounding problem. AI must integrate empirical learning, connectionist methods, probabilistic reasoning, integrate those into the structured framework that symbolic AI provides.
Okay, so let me see if I get this right. You use something like deep learning to handle the messy, ambiguous real-world data, to spot patterns, maybe generate hypotheses, provide that sort of intuitive feel for the context.
Yes.
But then you feed those outputs, those insights, into a structured symbolic system.
Precisely. To ensure logical reasoning, planning, consistency checking, verification against known rules.
That combination.
That hybridization is what could potentially give AI systems the ability to learn flexibly, adapt to new information, and maintain logical coherence and traceability. It's arguably the necessary next step if we want to advance towards truly cognitive artificial intelligence, integrating the power and flexibility of modern statistical learning with the rigor and structure of, well, Aristotelian deduction.
It really is fascinating when you trace that whole journey. We started with these foundational assumptions from Aristotle, from logical empiricism.
Right.
Watched those assumptions lead directly to the first expert systems. Then saw them kind of crash against the complexity of the real world through things like the frame problem and Dreyfus's critique, and realized that the ultimate philosophical roadblock, that grounding problem, is still, in many ways, challenging even our most advanced AI models today.
The final takeaway, I think, for you listening is that the path forward isn't a simple binary choice. It's not logic versus statistics or old AI versus new AI. If we want AI systems to be truly intelligent, truly useful, and maybe even safe, The discipline has to really embrace the challenge, the complexity of hybridization. It needs to move beyond relying solely on either its logical representational past or its purely statistical present.
Which leaves us with a really provocative final thought to mull over, doesn't it? If that core limitation of AI, even now, is still this inability to truly connect internal symbols to the real world, the grounding problem, and if so much of human understanding seems to rely on our physical bodies, our interactions, our embodied experience, what specific embodied experiences or complex contextual interactions would a machine actually need to gain genuine understanding? And maybe the bigger question, could that kind of grounded knowledge ever be fully captured purely digitally, without a body, without lived experience in the world?
That philosophical question, that's arguably what defines the entire next era of AI research. Where do we go from here?